All right, everybody, area of a regular polygon coming at you. So, regular polygons, remember, you have to remember a regular polygon is a polygon that has all congruent sides and all congruent angles. So in this example, every one of those side lengths would be the same, every one of the angles would be the same, like an equilateral triangle or a square. So this formula is only going to work for regular polygons. And the formula is 1/2 PA, where the P stands for perimeter, and the A stands for an apothem. So what we're going to do here is show you how that big old formula came into play. So we're going to, again, make some cuts into this figure here. So we made 6 slices, and basically those are just the distance from the center of this regular polygon to each vertex. And if we were to open it up and use this guy as a hinge, then you would have that triangle, and then we would right next to it put this triangle. And then after that, we would put this triangle. And then, as you can see, we would just keep on going. We would have this triangle right here. This triangle right here. And finally, the last triangle right here. And one thing that those all have to have in common, because this is a regular polygon, is they all have the exact same height. Every one of those little triangles has the exact same height. So that's where the height comes from. But the base, remember, this is a regular polygon. So the base for every single one of these is the exact same. So if we have a triangle formula of half the base times the height, and all of those bases add up to be just the perimeter of this entire polygon, and the height just turns into what's known as the apothem. That's how we get half the perimeter times the apothem. Okay? So if you have a perimeter and an apothem, you are good to go. You also are really good to go if you have just a side length. But that's going to require a little bit more work on your part, or a radius. So if you were to take a segment from the center to one of the vertices, that's called the radius of a regular polygon. But if you were to dissect it, it would be just the side length of the triangle. So here's a real simple example for you. And then we're going to spend a little bit of time talking about the second one. This was giving you everything. So if it's a regular polygon, remember, every single one of those sides is going to be 6. Since we have 5 sides and this is a regular pentagon, the perimeter is 30 units. And our apothem is given to us as 4. So our formula is 1/2 the perimeter times your apothem of 4. So that is just going to give us 60 units squared. Okay? So that's a very easy example, as is all area problems when they are given to you with all information that is required. But regular polygons can get pretty difficult if you are only given part of the information. It's still possible, but it's a challenge. Here's why. First thing you have to do is find some missing information. You do not need a radius for the actual area, but you're going to need him to help you find what the apothem is. So since this is a hexagon, all of the sides are 10. But once you get down here, you have a 5 and a 5. So that's pretty important to keep in mind. We're going to draw just this guy off to the side. And that's 5. Okay? So now I'm going to go back up to this example right here. If we were to look at the center, this angle, and that angle, and that angle, and that angle, angle, all of that is going to create a circle. So from here all the way to here is 360 degrees. So if we were to have a full triangle, all we would have to do is 360 degrees divided by our 6 different triangles, or just divide by the number of sides. In this case, it would be 5 different triangles you can create. Each one of these central angles is 60 degrees. So then over here, when we cut this guy, it was split into 30 and 30. So we know that this top angle is 30 degrees. But now you can just use 30, 60, 90 right triangle to find everything else that you need. So really, whenever you're doing regular polygons, you could just take one right triangle, and this top angle can be found by doing 360 degrees divided by 2 times the number of sides. And then sometimes you have a 30, 60, 90, sometimes you have a 45, 45, 90, and sometimes you have an angle that requires you to use trigonometry, but it can be done. So in this case, this is a 30, 60, 90 triangle. So as we've talked about these guys before, this is your S side, and this is your S root 3 side, and this is your 2S side, but like I mentioned, you're not going to need the radius to find the area. So all we needed is the apothem, which is 5 root 3, because our short side is 5. So now we go back to this entire formula or diagram here. Half of your perimeter, so each side is 10, there's 6 sides, so we have a perimeter of 60. Times our apothem, which we just found using special right triangles, is 5 root 3. And then all you have to do is multiply those guys together, and you have 150 root 3 units squared. Okay? So, as I said, if you have all the information, it's pretty simple. But if you don't, it's a little bit of a challenge. Okay? Last example is how you work backwards. So when you are working, we have 1/2 the perimeter times the apothem, and that's equal to our area. We were given that the area is 800, and we were given that the apothem is 10. So 1/2 of 10 times the perimeter. So 800 is equal to 5p. So divide both sides by 5, and we know that the perimeter is 160. But then you have to remember that there are 8 sides to an octagon. So we're looking for one side. The perimeter is 160. So if we just want one of the sides, we have to divide that by 8, and that will tell us that each side is equal to 20 feet. All right? That's it for this video. This is Longo, and I'm out. See you, bye.